Welcome back, Algebrists. This is 2.1, and we're continuing from this example. Sweet. Okay, right off the bat, we are using this form, and you saw it all day in the lesson, but this is what we use. This is our vertex form, and specifically where HK, these numbers, are the vertex. Vertex. Okay, we saw that the day before. You already have it in your notes. I just want to make sure we don't forget this. When we look at this thing, right off the bat, can you guys tell me what the vertex is?
1, 4.
Okay, do you guys all agree? Now, when you made tables in Algebra 1, you probably used 5 points. And my guess was 0, 1, -1, 2, and -2. Okay, now, we're going to use 3 points. There really will be 5, but we're going to try to save a little bit of time because parabolas, if I have half a parabola, it just folds over itself, and then we have the whole parabola. So if we get 3 points that do this, we have some line that we just reflect over, and then it just comes right here. Everybody cool with that?
Yeah.
All right, so here's how we're going to make our table. I'm going to use 3 columns because of scratch work. We have x, we have our function in the middle for all of my scratch work, and we have the y value that it spits out. And all we need is 3 points. Now, you might not have this just right away if I just ask it, but I'm going to make a claim, and I want you guys to tell me if it seems reasonable. The vertex is an important point on a parabola. If you were graphing all 5 points and actually going to plot them all, you would have the vertex right in the middle of your table. I'm not going to put it in the middle of my table because I'm only going to use 3 points. If it bugs you that we're not writing all 5, we could put it right in the middle, but I want to see if we can do it without it first. What is the x value of the vertex? So I'm going to double check. I know that when I plug in a 1 to this function, what should it spit out? It should be a 4, but let's verify that. When I start plugging in, and I'm going to do a little bit of mental math here, but I won't on the first. What did we just say we're going to plug in for this x? Okay, so do you agree that inside my parentheses, I get this? Okay, and it's still squared plus 4. All I've done is I plugged in the 1. Now, here's the mental math part. I don't necessarily need to see this every time, but I think that you guys can tell me, what am I going to replace my parentheses with?
0.
Everybody agreed 0. And I said a minute ago that we want 0 because 0 is easy to square. So I'm going to do one more line of work. This is -3 times 0 squared plus 4. Everybody agree? All right, now help me out. What's 0 squared?
0.
Times the -3?
0.
And 0 plus 4? Check it out. We got 1/4. That's what I was expecting, but I can see that it did indeed work out. Okay, this question is going to get asked about 1,000,000 times as we're graphing these. We just did 0 squared, right? Like I worked out nicely. It's easy. What's the next easiest number to square? 1 is easier than 2. We'll use 2 again here in a second. But nope. So you're looking at this one, right? I'm not saying what x should we plug in. I want 0 squared is what I got when I had x equals 1. Whatever my next value is, it would be awesome if I could do 1 squared instead. So, little mental math or scratch work. Is there a value of x that makes whatever's inside my parentheses, the thing I'm going to square, equal to a 1 instead? Okay, it is not 0. That'd be a -1. If you don't know that off the top of your head, what's the stuff that's in parentheses right now? X minus 1. So the scratch work is, what value of x do I need to pick to make this a 1 instead? And it's 2. And I can solve this, plus 1, plus 1. Okay, it's x equals 2. Now, I'm going to use that x value for my second choice. We're going to try a little mental math. If I pick x equals 2, inside of my parentheses, what remains here? 2 minus 1 is what? So squared plus 4. We are only mental mathing that one little tiny part because I think you guys can all do 2 minus 1 is 1. Okay, now help me algebra this out. What's 1 squared? Times -3. And we now have -3 plus 4, which is a 1. We have our second point. Before we move on, any issues there? Now, notice, the first time we did 0 squared, which is super easy. The second time we chose an x that made it be a 1 squared. What's the next easiest number?
Make it a 2.
Is there a value of x that I could pick that when I do x minus 1, it's a 2? So my scratch work could be here. X minus 1, I want it to be equal to 2. What x do we choose?
3.
So I'll clear this. We'll do it with a straight line. And I'm going to extend this table. You just told me to pick 3, right? Find me the y value that 3 spits out at us. You're doing the middle column independently right now. If you get it and you're confident in your work, your answer, check with your neighbors. See if you guys can help each other for just a second. Going okay over here, guys?
I got 8. I got -8. Same. -8? Yeah.
So I'm going to check. We have -3 times, what's 3 minus 1? 2 squared plus 4. So this is -3 times 4 is -12. Plus 4 is -8. Okay, looking at this. Anything but -8 for anybody here? Do you see anything? Okay. I'm sorry? Yeah, no, that's okay. All right, so check it out. We're now going to graph these 3 points, and we're going to see why. Do you guys remember using 5 points to graph quadratics? Do you ever remember using 5 points to graph quadratics? Okay. Did you always use 3? Cool. All right, so check it out. I see that I have from 4 to -8 on my graph, so I'm going to focus like here-ish. Now, when we pick our scale, what I would always recommend, I need to go up to 4, right? So that's the biggest y value that I ever see. So luckily for me, I see that there's 2 little ticks. I'm going to say that that's 2 and that's 4. How far down do I have to go on my table? So here's -2, -4, -6, -8 is all the way down here. Everybody okay with that? All right, in the x's, right now I need a 1, a 2, and a 3. Because I have space and I didn't think out this table a ton, here's my 1 and 2 and 3. It's okay that they have different scales as long as it's consistent all the way across the x-axis and consistent all the way through the y-axis. All right, so check it out. I'm going to plot these 3 points. Here's the point 1, 4. Here's the point 2, 1. And here's the point 3, -8. When I look at these 3 points, does it look like half of a parabola? Now, remember that thing that we spoke about just a minute ago. If I have half a parabola, every parabola ever is symmetric about itself. What I would encourage us to do, it's never required, but I think that I could probably draw my line right through a vertex and say, let's just reflect over this thing. Okay, this is my axis of symmetry. It happens to be the x-coordinate of the vertex. Now, my other 3 points, instead of making them on a table, we'll just do them right here. If I'm at this point, I'm 1 away from this line, right? So I'm going to go 1 to the other direction, and I'm going to plot the same y value. This point is 2 away from this line. So I'll go to that y value, and I'll go 2 away from it, and I get my 2nd and my 4th and 5th points for free. Can I now draw my parabola through here? I have a wonderful parabola graphed, ready to go. I want you guys to try the assignment. We did not have time just now to work through the domain and all that stuff, but the table and graphing, always vertex, and then 2 additional values on either side. We could have chosen 0 and -1. It would have worked fine. 2 and 3 were what we chose here. You might need a little bit of scratch work. Peace out. All right.